Classification systems, we use them all the time and they always have a purpose. For instance, you might classify people according to their gender, or their age, or their major, or the year they are in school. Or you could think about foods and to proteins and fats and vegetables. So you're well familiar with classification systems. Now we're just going to talk about them in the context of soil. And in soil, they're always use-specific. For instance, you can have wetlands. We can rate things according to their agricultural potential, according to their suitability for irrigation, their as source material for reclamation. And we can classify soil just because it's there. So if we start with wetlands, wetlands must always meet three characteristics. They have a certain hydrology. That's a water table present, either in the soil, below the surface, or sometimes above the surface, at least during some part of the year. They have obligate or facultative hydrophytes. This means that they have plants that either must live in the water, think of cattails that you almost always find in the water, or facultative plants. Those are plants like reed canary grass that can live with their roots in short periods of inundation or in soils that are saturated most of the year, but also survive when there's plenty of oxygen in the root zone as the water table is dropped. And then the soils themselves are classified, and there are lists. Each state has a list of hydric soils. And we'll talk briefly about the characteristics of hydric soils, but you'll see more of those potentially when we go into the field for lab. Another common system is the land capability classification system. This one rates land according to its highest agricultural use potential. In so doing, it considers the most limiting factors to using that land for crop production. It rates them on a Roman numeral scale from 1 to 8. And if we start with Class 1, that is the prime farmland, the best land that has the fewest limitations for its use. It requires the fewest special management practices. And in many states, it's protected against urban and industrial development. In other words, they want to keep that land in agriculture rather than allowing it to go into some other use. So briefly, classes 1 through 4 are suitable for agricultural crop production requiring tillage. And Class 1 land is the one for the most intensive use with good management practices, whereas you go all the way down to Class 4 and it's limited tillage crop production. You have to apply the best management practices in order to use that land for agriculture production. In Classes 5 through 8, this is land that's generally suitable for perennial crops, not annual crops, or not those that we're plowing and preparing the land to plant and harvest. Class 5 land is often wetlands, and it should not be in crop production. And Class 8 land is best use is environmental conservation, wildlife, recreation, things of that nature. The subclasses is a secondary characteristic or breakdown in this land capability classification system. This uses lowercase letters, and each letter has some specific meaning, such as E for an erosion hazard, and if the E is there, then conservation practices are required. W, wetness is the major limitation. S, the root zone or special soil limitations exist, things like shallow soils or stony soils or saline or soils with extreme pHs. C is an extreme climatic conditions that might exist. So really hot, really cold kinds of things there. And in semi-arid regions, the map units are assigned 2 land capability classes. The first, just like we did earlier, and then the second, it'll assign an irrigated land capability class to identify the potential of that land with irrigation. However, that does not indicate that the land will be irrigated, just what would its potential be if it were.